Hello, class. This is the review I put together for this year, for this spring, covering units 7.5 through 8. So basically since the last midterm. So it's a fairly short final exam. I gave you some examples here. For the multiplication, I only gave you one of each type. One of the multiplication, then I gave you two for dividing, because I wanted to show you a different way of dividing. So to multiply, use the box, especially when we're dealing with something like this. This is pretty long. So you have, let me just write it. You have x to the fourth minus 2x cubed plus x squared plus 4x minus 12. And down the side you have, I'll use a different color, 2x cubed plus 3x squared minus x minus 9. Now this is larger than the one you're going to see on your, they're longer polynomials, but the process is the same. All right? You have a column for each term across the top. 1, 2, 3, 4, and you have a row for each term going down the side. So we got 1, 2, 3, and 4. So we actually we're multiplying two very large, they're not trinomials, they're what, quadnomials, I guess. There's 4 terms in it, 1, 2, 3, 4, 5 terms in each. 1, 2, 3, 4, 5, 1, 2, 3, and then 4 down the side. So just filling this in now, I'm going to make it big so I can write there. So you get, let's see, let's go pink because it'll be staring at you. 2x to the third times x to the fourth gives you 6x to the 3 plus 4 is 7. 2x to the third minus times a negative 2x to the third is a negative 4. X to the 3 plus 3 is x to the 6. 2x to the third times x squared is 2x to the fifth. Notice the exponents are going down by 1 as we move across. Oops, sorry, that's the wrong button. I want to go, where is it? Right there. Oh, no, not right there. That's the wrong thing. I want to go right. Where is it? Oh, there. Okay. So 2x cubed, or excuse me. Yeah, 2x cubed times 4x is 8x to the fourth power. And last, 2x to the third times negative 12 is a negative 24x to the third. Okay, then we have, going down, I'm going to stop talking about, I'm just going to start doing it. 3x, I'm not going to circle. 3x squared times x to the fourth. Make sure you understand that x to the fourth is by itself. It has no constant in front. That 3, this 3 right here, is the exponent on that x. So I'm going to see if I can make it smaller. I don't know if I can. Okay, so anyway, we have 3x squared times x to the fourth is going to be 3x squared times x to the fourth is 3x to the 6th. 3x squared times a negative 2x is a negative 6, and that 2 plus 3 is 5. 3x squared times x squared is 3x to the fourth, because 2 plus 2 is 4. 3x squared times 4x is 12x cubed. 3x squared times a negative 12 is a negative 36x squared. Okay, I'm going to pick up the pace because this is pretty straightforward. Negative x times x to the fourth is negative x to the fifth. Negative x times a negative 2x cubed is a positive 2x to the fourth. Negative x times x squared is a negative x cubed. Negative x times 4x is a negative 4x squared. And negative x times negative 12 is a positive 12x. Okay? And I'm sorry, this last negative 36 is supposed to be x squared. Right there, I just saw that. There's a reason I realized it, and I'll explain that at the end. All right? Then you got negative 9 times x to the fourth. Negative 9 times negative 2 is 18 x to the seventh. Negative 9 times x squared is negative 9x squared. Negative 9 times 4x is negative 36x. Negative 9 times negative 12 is positive 108. All right, so we got all these terms, and it'll be mind-numbing, but since we organized it like this, you'll notice that you'll have, in order, in order, you'll have 6x to the seventh, and then you add up down the column or down the diagonals. So those are the only x to the 6, so that'd be negative x to the 6. Then these are the only x to the fifths. So you got negative 1 plus a negative 6 plus 2, negative 7 plus 2 is negative 5, x to the fifth. Going down, you have these. So there's quite a few of them. So you got negative 9 plus 2 is negative 7, plus 3 is negative 4, plus 8 is 4. So we have 4x to the fourth. Then our x cubed will be right. Wait, why did I write 7 there? I'm so sorry. That should be, see? Even the best of us make mistakes. Everybody makes mistakes. Everybody has those days. Okay, notice I caught that because x to the third, x to the third, x to the third, and that had to be x to the third. So we got 18 plus a negative 1 is 17, plus 12 is 29, minus 24 is 5. So it'll be plus 5x to the third. I'm running out of space. And then we go to x squareds, which are these. So we have negative 9 plus a negative 4 is negative 13 plus 36, or minus 36. So negative 13 minus 36 is negative 49, if I'm not mistaken. And that's x squared. And then, just like before, here's the x's. 12 plus a negative 36 is negative 24. So I'll just have to write here, minus 24x, and then the 108 just comes along for the ride. And there you go. Kind of a long process, but you see this box makes it so much easier. All right? The next one, divide polynomials and simplify the quotients. Now, you know how to do it the long way and the painful way. I am now going to show you the quick and easy way. This is called synthetic division. And it basically goes like this. Instead of making the, replicating this box up here, when we're dividing by a binomial, like this, a linear binomial, okay, then what we're going to do is called synthetic division. And it's so much easier. I've already showed a couple students in my advanced algebra classes who came in for help, and they thought it was like infinitely easier. First of all, you're going to make sure that all the exponents show up. That means if you have x to the third, you need x squared, x, and then a constant. If that's not showing up, you have to put a 0 in for that spot. Then you're just going to put the coefficients down. So what does that mean? The numbers in front of the variable. So we got a 1, a negative 2, a negative 14, and a negative 5. We do this just as a way of organizing. And then if we're dividing by x plus 3, we're really checking to see what the value, we have to change the sign of the 3. All right? Negative 3. That's key. Plus means negative. Okay? So now just drop the 1. Then go negative 3 times 1 gives you negative 3. Now add. Negative 2 plus negative 3 is negative 5. And then, again, just replicate. You got negative 3 times negative 5. That gives you a positive 15. Now add. Okay? Right here. And negative 14 plus 15 is 1. Then, again, negative 3 times 1 gives you negative 3. Add. And you get negative 8. All right? So, here's the dealio. What you just did was divided. You might be saying, what? What do you mean divided? Well, we started with an x to the third, and we divided by x plus 3. X to the first. So, x to the third divided by x, well, you decrease the exponent by 1. So, this is x squared. This is negative 5x. And this right here would be plus 1, or 1, all right? And then this right here is that pesky remainder. Remember you had to kind of backtrack what the number had to be? Trying to replicate this box up here, which is a nice method, but it's just very complicated. And very, oh, come on. There we go. Why is that not erasing? There it goes. All right. So what we would do is these are the coefficients right here. This, that, and that. If this was x to the third, it's now going to be 1x squared. And if it was negative, and this was, and then this term would be the negative. So this is x squared. This is going to be x, and that's going to be the constant term. So you just write down x squared minus 5x plus 1, and the remainder, you're just going to say plus a negative 8 over x plus 3. And that is the quotient. It's really short and easy compared to this method of trying to replicate. And notice this is ugly looking at that. You can still use that method, but you would get this exact same answer. So try B here. Pause the video and see if you can get B. All right, so to divide, you take the coefficients in front of the polynomial 1, negative 13, 40, and 18. Okay? And then remember, it's going to be the opposite. So if we're dividing by x minus 7, we're going to put a 7, a positive 7 over here. Okay? And then drop it. You get 1, 7, what is that, negative 6? Times 7 is what? 21, negative 42. Add, that's negative 2. This right here, whatever shows up here, the reason I draw this line here is because whatever number is here is the remainder. So 7 times a negative 2 is negative 14. Add, and you get 4. So since this was x to the third that we started with, this is going to be x squared minus 6x minus 2 plus 4 over x minus 7. And that's the answer for 2b, or not 2b, for that is the question. So you see this division process, which works only for dividing by linear binomials, is a nice little trick to get this done quickly. The reason people used this in the past is because before there was graphing calculators, we had to find the zeros of a polynomial. You had to use some tricks. Something called P over Q, where P is all the factors of the last number, of the constant term, and Q is all the numbers of the lead coefficient, factored out, all the factors. And then you start doing ratios until you find the right combination. So you would do it this way because it makes it easier. Now that we have graphing calculators, not so much. All right. They give you the fact that x equals 2 is a root. That means x minus 2 is a factor. So what we're going to do is take this polynomial and divide it by x minus 2. And I'm going to do it by the synthetic division process. So remember, we do this, and we write the numbers 5, 4, negative 20, and negative 16. Okay. I always draw this line because I know that whatever's here is going to be the remainder. Now, if x minus 2 is a root, this remainder has better be 0 because it goes in evenly. So, and then since we're dividing by x minus 2, we put the opposite of negative 2, or positive 2 here. And then we just drop the first term. 2 times 5 is 10, plus 4 is 14, times 2 is 28, plus a negative 20 is 8. 2 times 8 is a positive 16, and lo and behold, look at this. Negative 16 plus 16 does indeed give us 0. So we know that these are the coefficients of 1 power less than what this was. Since that was x cubed, this is going to be now going to be 5x squared plus 14x plus 8. And then the other factor is x minus 2. Okay, so we started factoring. Now we have to factor this in the parentheses. Easiest way to do that, since it's quadratic, it's a trinomial, is look for product sums. So remember, it's going to be 5 times 8, which is 40. And it has to add up to 14. Well, I hope that's obvious. It's 10 and 4. All right, then what we're going to do is make a smaller box. Put the first term, 5x squared, there. Put the last term, 8, there. And then put, what were the two factors? 10 and 4. So this would be 10x and 4x. Then we're going to, what we do is, we GCF, just like before. What's common between 5x squared and 10x? That's going to be a 5x. So we pull a 5x out. What's common? Then you ask yourself, what do you multiply 5x by to give us 5x squared? And you'll say x, I hope. So this is x. And then you can fill in, you can look here, 5x times what gives me 10x, and that's going to be 2. And then to figure this piece out, right down here, you have to ask yourself, x times what gives me 4x? And I hope you'll say 4, positive 4. So, we just factored that ugly this. We know that it's going to be in factor form, x minus 2. Then it will have x plus 2, that came from here, and 5x plus 4. All right, and the roots are going to be 2, negative 2. And the last one, you have to set 5x plus 4 equal to 0, so that's going to be negative 4/5. And there you go. It's a lot easier to do the synthetic division. Again, synthetic division only works when we're dividing by like an x minus 2, or in this case down here, since x equals negative 3 is a root, we're going to be dividing by x plus 3. Okay? Because it's the opposite, right? So now, when you look at this one, I would say you should always try to GCF. This one should be GCF before we even try to divide it by the known factor of x plus 3. All right, so what do I mean by that? You can pull an x out. And then we get 2x cubed minus x squared minus 18x plus 9. All right, and now I'm going to divide x plus 3 into that. So here I go with my synthetic. It's going to be 2, negative 1, negative 18, and 9 across there. And then down, then it's going to be, since we're dividing by x plus 3, or since they told us the root is negative 3, we put that negative 3 over here. And then it's just a process of dropping and multiplying. Because we know at the very tail end, we should get 0. We better get 0 or there's an issue. Either we messed up with our division or x equals -3 is not a root of that polynomial. So -3 times 2 is -6, plus a -1 is -7. -3 times -7 is positive 21. -18 plus 21 is 3. -3 times 3 is, look at this, -9. And yes, just as advertised, 9 plus a -9 is 0. So now that means once you divide by x plus 3, we will have 2x squared minus 7x plus 3 as a quadratic. So now this is factored as x from the GCF. Then we'll have x plus 3. And then it will have 2x squared minus 7x plus 3. And our last step is try to factor this. Okay? So that's fairly straightforward, at least I hope. You're going to look for two numbers that multiply to 6, adds up to -7. I hope you understand that's going to be -6 and -1. Okay? And then to finish this off, we have to kind of do the box again. We know that the first term was 2x squared. And we know the last term was 3. And then this has got to be a -x and -6x. Doesn't matter where you put it. In other words, you could have flip-flopped these two and you'll still get the right answer. These two have been switched. Okay? And then you look, what's common between 2x squared and -x? Well, that's an x. I want to use a different color. Let's use red. So there's an x that can be pulled out. And then you realize this has to be a 2x because x times 2x gives us 2x squared. And then you ask yourself, x times what gives me -x? And you'll say -1. Okay? And then that's one of the factors. The other factor you'll ask yourself is, okay, 2x times what gives me a -6x? I hope you can see that that's -3. Okay, so we just factored this polynomial, all right? We had, and think about how ugly it was. We had x parentheses, x plus 3 parentheses, x minus 3 from here, and 2x minus 1. And we factored that ugly mess right here. We factored that. So once it's in factor form, it's easy. You'll get 0, -3, 3, and this last one will give us 1/2 as our zeros. Okay? All right, I'm going to pause here and create a second video to do 4, 5, 6, and then a third video to do 7, 8 through 10, I guess. All right? So there'll be 3 videos for this. All right, so I'm stopping here. I'm going to pick up on question 4.